have a brief introduce about our monitoring system, including the app, how it's used, and our web and the service pages. And this is a diagram of our monitoring system. Firstly, our inverter with Bluetooth built in. So on our app, you can use Bluetooth to connect to inverter directory and do local monitoring and local configuration commissioning. And then when inverter install the Wi-Fi dongle, and the data will be sent to server, and then customer can have remote monitoring both on app and the web. Besides, for our service team, they have a service account, and when they log in, they can acquire end user for monitoring and management. Besides, they can also have remote setting or remote upgrade to the inverter. So this is the diagram of our monitoring system. And this is our app. And on our app, you can see it's including two parts. First part is about remote account login for both end user and service. And the second part is about local function. We can see there is a Bluetooth connection available here. So now we try Bluetooth connection. And then here we can scanning the serial number of inverter to connect to inverter. And we can also click the menu connection here, and then the app will show available devices nearby. So then we can click the device to connect it to it directly. Now I have one inverter behind me and it's available. Okay, now when the first time when we connect to an inverter, there might be a notification. For example, inverter time wrong. That means that's because inverter clock after a long-term ship is maybe different from your mobile phone. So he gives this notification. And here usually we need to click OK to synchronize our mobile phone to the time of our mobile phone to inverter clock. And then now we reach the homepage of the app. In the homepage, firstly, we can see there is a power map, and there are several icons of PV, grid, inverter, and the battery. And in this power map, we can see the basic state of each part. For example, the PV now is in gray. That means PV is not connected or PV switch is off. And also grid is in gray. That means the grid is disconnected or grid switch is off. And now we can see battery is blue. Oh, there is a battery available. And also the generator and the backup load and the normal load. So from this power map, we can see the basic state of our system and the state of each part. Except besides the power map, there is another, we can see there is a yellow speaker near the power map. Here we can click it and find the real-time alarm of our inverter. This is a very useful function because this yellow speaker is display the real-time alarm of inverter. So we can read the alarm and take actions to solve the fault. For example, now inverter is report grid under frequency, grid absent, grid under voltage. This three alarm that's about AC side. So we can go to check whether grid is connected or whether AC breaker is off. And for example, the GN voltage abnormal, then we can go to check whether the generator have output voltage like that. And then the next one, D8, communication loss between inverter and BMS. Okay, that means there are something problem between the communication of inverter and the BMS. So in this case, we can go to check whether battery and BMS is turned on, or whether the cable, BMS cable is correct, or whether the pin is matched. This is a very useful function on plant. We can see the real-time alarm of inverter. Then we take actions to solve them one by one. But here we can see I didn't connect AC, so it's giving this alarm, and it's give the alarm generator voltage of the number. That's also because I didn't put the generator input, and it's give the communication loss between inverter and the BMS. That's because I didn't insert the BMS table of the battery side, because even on inverter side, I insert it, but on the battery side, I disconnect. Now I put it. Go back to the page and refresh it. Okay, now we can see the alarm D8 communication loss between inverter and the BMS is disappear. That means this alarm is cleaned and we solved one. And if we put on AC and put a generator on, then the other alarms will also disappear accordingly. So this we can take actions according the alarm inverter report on plant to solve the problems. Just now we clean the communication loss alarm between inverter and the BMS, and now we can also slide down to check the details. For example, now BMS side share the battery information. Now its SOC is 20% and its temperature is 26 degrees and the voltage is 15 volt. Okay. This is about the homepage, the power map, and the real-time speaker, real-time alarm list. And then on the homepage, when we slide down, we can see the detailed parameters of each part. For example, we can see the PV input information, its voltage, its current, and its power. We can also see grid voltage, current, and the power, and also the load, the battery information, its SOC, its voltage, its current, and also the parameters of backup output, the parameters of generator port. This is about the homepage, app homepage. And then next page is the quick setup. Here we have a quick setup manual 1, 2, 3, 4, 5 to guide our customer how to complete the installation after they mount the inverter. First step is to configure the Wi-Fi connection, because many customers he will install the Wi-Fi dongle and do the remote setting, do remote monitoring. So he needs to do the Wi-Fi connection here. And the second step is to confirm the standard code of inverter. Inverter will set a default code when we doing our production. For example, in South Africa, it would be NIS 097. And here you just make a confirmation whether the standard code is matching to your country, and also we confirm the nominal voltage and the frequency. And also we double check the date and the time of inverter, because some customer may use the function of time-based control. In that case, in that situation, the inverter clock match to actual time is very important. So we can click it to synchronize the time of inverter to our mobile phone again. Okay, the third step is about export power control. Because this is to set the devices. We select the device we are use for export power control. Defaultly, we provide a CT sensor together with each inverter, and here just select the CT sensor. If any customer he use a digital meter, he can select the digital meter, and then we can select whether we clamp the CT is clamped on grid side or is clamped on load side. Customer do the selection based actual installation, and then he need to select the power flow direction. On the CT sensor, there is a low mark here. In this part, maybe it's not very clear, but when you take a CT, you can see it. Power flow is from grid to inverter, or is from inverter to grid. So customer also need to do the correct setting according to actual installation. The meter location setting and the CT direction setting is very important for system running, because the CT is used to detect the power exchange between our system and the grid. If it's detected, I purchase power from grid, then inverter will discharge battery or increase PV power. If we clamp the CT in wrong direction, it will data wrong value to inverter. In that case, inverter behavior will get wrong. So need to pay attention about this point when you install the inverter and when you do the setting. The last part is about maximum feed-in power. That it is to set the power, maximum power to feed to grid. If the plant is allowed to feed the power, you set the value accordingly. If it's not allowed, you set to 0. Then the system will 0 feed into grid. The logic is, for example, the system is running and then customer turn off load, then there will be some excess energy and it will go to grid. At the same time, our CT sensor will detect, can find, there are some power go to grid, then it gives signal to inverter. Currently there are 1 kilowatt power go to grid, and then inverter will take action. I reduce my discharge 1 kilowatt, or I reduce my PV generation 1 kilowatt, and then there will be 0 export to grid. So this is the function of CT, and we can say it's export power control. Okay, the first step is about the hybrid setting. In this setting, customer can set the working mode. In our inverter, we have 3 basic working mode. First one is self-consumption mode, and the second is feed-in priority mode, and the third one is backup mode. Different customer install the system have different purpose. Some customers say, I just only want to self-consumption to reduce my electricity using from grid. But some customers say, I want to use it as a backup source. I want to back up energy to against the grid power outage. So it's like a backup mode. In this point, customer setting the working mode as the actual demand. And then here customer can also do the setting of battery selection. Here we have some white list here. And for your inverter, I'm not sure whether maybe it was in soda battery, so you can ignore. And then the fifth part is to power on, to start up the inverter. So we click the icon is to power on, power off it. Okay, we power inverter on, and then sorry, maybe some alarm didn't clear, so it caused the power on failed. Okay, this quick setup menu is also very useful to guide our customer, to guide our installer finish installation of a plant. The necessary step you need to do on the plant. This is a quick setup menu. And then next page is about generation chart. In the generation chart, we can see the generation code of each day. We can also switch day. We can check the data of yesterday, the day before yesterday. And here we can also switch the view by month. Okay, by month, we can see the generation data of each day. We can also switch to year. And at this view, we can see the generation and the consumption power of each month. Okay, this is about the generation chart. And the next one is the log page. In the log page, we can see all history logs. Another information about here is the city we provide together with our inverter is defaultly is 3 meter. We have 10 meters city option. So you can tell your commercial team if any customer require the 10 meters city. So for 10 meters, it may be better for many installation. And if 10 meters is still too short to any plant, to any installation, maybe you can consider install a meter, the digital meter. Currently, for the single phase, our inverter compatible with Trend DDSU666, that one. If you installed at a wrong location when you installation and when you went back office and you recognize all is wrong, you can take the changes on app.
And then we can change CT direction.
Yes, you can change the direction. No battery is okay, but it will work as an on-grid inverter. It's required PV and the grid to supply a load. It cannot work with only PV and the load, no grid, no battery.
In self-consumption mode, will the inverter still provide backup?
No.
Or it won't provide backup. So if grid fails, will it use the battery?
Yeah, it's okay. In self-consumption mode, when grid is off, then at that time, inverter will take power from battery to supply a load.
For commissioning, must there be AC? Must there be AC to finish commissioning? Or can we commission without AC power, grid power?
It's okay. No problem. When you install the inverter, if there is no AC, you can also finish the installation.
Commissioning, okay. Okay, thanks. We can move on. Thanks, Lincoln.
Okay. Let's continue about the history log page. The history log page shows all history that recorded in inverter, and we can see the state of the fault. For example, the first two is one of it is CJ meter loss. It's active, and the second one is a CJ meter loss inactive. So here we can see the alarm when it happened and when it disappeared. Next page is about inverter console. And in this page, firstly, we enter the maintenance page. In this page, we can see the basic information of inverter. For example, the model name, the serial number, and its firmware version. And here are some maintenance operation available. For example, power on the inverter, power off the inverter. Power on, power off here is the same as the quick setup step 5. So you can do here, you can also do there. And then next tools are factory reset and clean historical information. Is to reset all settings as a factory or is to clean the historical generation data. And the next part is data management. With this, we can export the generation data to our mobile phone. And the last one is about app version information. And the second menu is access management. Defaultly, when a new mobile phone connects to a new devices, it will be in guest mode. And he can only go through quick setup. If he want to do the other settings here, he need to log in as administrator. And the default password is admin. So we can switch the login as administrator here, or we can do login as admin, and now I can enter this page. This is access management. And the third one is the communication setting. Actually, for the Wi-Fi communication setting, I recommend to do here in the quick setup. And the fourth one is about grid parameter. Here showing the detail of grid parameters. Mostly standard code, and also some other information is identified by the grid code. For example, the South Africa grid standard code NIS 0997 is identify the first connection delay time and the reconnection delay time as 16 seconds. That means after we put power on our app, inverter firstly will have a self-inspection to the system. For example, whether it's PV isolation abnormal, or whether it's grid whether there is a leakage current alarm, or whether there is other alarm. If the self-inspection is okay, then inverter will start up, and then it will have time countdown 16 seconds to connect to grid. This is the first connection time delay. And the reconnection time delay, that means when our inverter is running and then grid stop and return. At this moment, inverter is not connected to grid and feed to grid right now. It will wait 16 seconds. This information is identified by the by a country's regulation. So defaultly, we cannot change it. But in test environment, for example, in our library, we don't want to wait such a long time. We can change it to 10 seconds or 20 seconds. And also the first connection power gradient and the reconnection power gradient. That means when an inverter connected to grid, the South Africa regulation identify you cannot generate at 100% of rated power during connect and reconnect, because you feed in too much power to my grid, it will avoid the stable of my grid. So here there are some identification here. In first minute, in every minute, you can increase 9% of your rated power. So here is the power connection, the connection power gradient of each minute. And then next things are about frequency protection point and voltage protection point. These are all the default settings, and the protection point, that means, for example, high voltage protection 215 volt, and the low voltage protection is 195.5 volt. That means when grid voltage is in this range, okay, I keep connect to grid. When grid voltage, for example, grid voltage now is 216, okay, and I have to I will disconnect to grid. Or if grid voltage is too low, 180 volt, I also have to disconnect from grid. This is about voltage and frequency protection point. As to our inverter, it's okay, and the range can be maybe 290 or even 300. For our inverter, we have the ability. Our inverter is okay, but just as I mentioned, 253. This point is identified by NRS. So
Yes.
it's better to get the permission from grid operator. If with the permission of a grid operator, you can do that.
What will happen if we get to 253? Does the inverter disconnect from the grid and go supply the load from battery, or does inverter go into fault?
Inverter will disconnect from grid and supply the load by battery. The next menu is about the feature parameters. It's about the protection parameters that implement in inverter. For example, the islanding detection or the insurance impedance or leakage current point. Yeah, these are the default protection parameter of inverter. Here, I do not recommend to change here. Another information here is about rated power, 110%. This is to set the rated power of inverter. For example, for our 8 kilowatt inverter, it have 10% overload ability and for continuously. So here, if we set 110, that means the maximum output of 8 kilowatt will be 8.8. If we change it to 10%, then the maximum power of inverter will be only 800 watt. Next part is also the power limit page. Here you can also do the same as a quick setup. And here one more setting is maximum permit consumption power from grid. This setting is about zero export, because when a system set in zero export, when we turn on or turn off some load, inverter maybe some tolerance for the detection of CT, and there are also some tolerance on the detection of inverter output. So there might be some small current go to grid side when we turn off or turn on a load. So to against the small current go to grid, we can set a value here, for example, 15 watt. I always pushes 15 watt from grid to against the small power to grid. So with this setting, we can achieve absolute zero export to grid. If you are allowed to feed into grid, you can ignore this setting. This value cannot set too large. That's because we can consider this setting as always pushes from grid 15 watt or 100 watt or 500 watt. So there will be problem if you set to a large value, for example, 5 kilowatt. Then if you set a 5 kilowatt, it will be always take a 5 kilowatt from grid to supply your load rather than discharge battery. Next part is about reactive power control. For residential inverters, it's not common, and usually it's for big inverters. So we can ignore this page. And the next part is about other setting. And here we can see the data, and we can see the clock of inverter again. And here we can also see the some other functions. For example, arc fault detection. But on your inverter, there are no this function. But some customer may enable this, and you can ignore here. The last one is the one we usually use is a hybrid setting, and in this menu there are working mode setting and the battery parameter setting and the backup load setting, and also the setting of generator port and the other setting. Yeah, this is the working mode setting, and the customer can also set the working mode, and he can also enable the time-based control. And the time-based control with higher priority than working mode. That means when I select self-consumption mode, I can enable the time-based control and set the charge period or discharge period. and the charge period, the discharge period, I said will higher priority than self-consumption mode. And during the charging discharge, there are 3 groups, total 6 period available, and the customer can set the start time and end time, and also it's repeat one day or repeat every day, or it's a charge power and SOC.
End state of charge. There you have it, 50%. Does that mean that the customer is going to be, or the inverter can use 50% of the battery up to that discharge end 50%, and the rest of 50% is for off-grid?
Let's consider a situation like this. Now, my inverter is set in self-consumption mode, and at some hours, the electricity price is very cheap. So I want to enable grid charge to my battery at least 2 hours, and I can set a charge power of this 2 hours, and I can set a charge and SOC of this 2 hours. This is the function of time-based control. When grid is available, I want to discharge my battery, but I don't want to it's discharged to a very low SOC, because I want to reserve some energy for off-grid use. Here you can find in battery setting, you can find there is a discharge to 20% and discharging and SOC for on-grid condition. So for these 2 settings, discharge to 20, discharge to 15. When grid existing, the discharge and SOC is 16%, and then discharge and SOC to 20%. That means when grid is okay, when grid existing, my battery will only discharge to 16%. And then when grid is off, it will continue discharge to 20%. This is the 2 settings. So they are.
So for the 5 kilowatts to get 5.5 kilowatts, how much battery, if we're going to be using the Sunwoda battery, do we need 2 battery on the 5 kilowatts, or is one going to be enough? For maximum outputs for inverter.
For our 5 kilowatt inverter, the maximum output ability is 5.5. And let me make a calculation. For our 5 kilowatt inverter, there is the ability of 10% overload. So it will be 5.5. But we have to consider the efficiency of inverter. We consider is 19%. So in that case, it will be required about 6.1 kilowatt DC side input. And then we consider that is a 15 volt battery. So for battery, it should have the ability to support around 120 ampere. Okay, this is the battery setting page. We can set the max charge discharge power. We can set the charge and SOC and the 2 level discharge and SOC, one for on-grid situation, one for off-grid situation, and the customer can use it as actual demand. Below, its inverter will trigger Fox charge, and it will use grid and PV to charge together. It's to protect battery.
First time commissioning inverter, we get battery. Battery is maybe at 30% state of charge. Now we want to charge the battery to complete our commissioning. Do we force charge battery to 100% here on this page?
Actually, I do not recommend you use Fox charge. I recommend you switch to backup mode to use grid and PV to charge it fast, to make its SOC go to 100%. Then you switch back to self-consumption mode or something else. For the Fox charge, default is 10% start and 20% stop. this function is to protect a battery, not used to other purpose. On our app, there is a fast charge setting available, and on BMS side, I think for good BMS, it also have his logic of fast charging. For example, when the cell voltage is very low, it will check a BMS fast charge and report to inverter. I need a fast charge. I need a fast charge. At that moment, inverter will also respond to requirement of BMS charge. BMS, and the inverter will also fast charge to battery to protect it. So for fast charge, inverter have the setting, and the inverter will respond to battery to BMS requirement. These 2 points. When grid is stopped, and if PV is enough, it will firstly supply the load, and if there are more energy, it's to charge battery. If PV is not enough, then battery will discharge to supply the load, and it will discharge to this point. It depends on the working mode. If it's a self-consumption mode, it will not use grid to charge battery, because for self-consumption mode, the purpose is to use more local energy and less grid energy. So in self-consumption mode, it will not use grid to charge the power. In backup mode, the battery will only discharge when grid stop. The last setting is about a grid charge. Customer here can enable grid charge or disable grid charge. If disable grid charge, that means in backup mode, my battery will only charge by PV. I will not use grid charge in backup mode. If customer enable grid charge, then inverter will use both PV and grid to charge battery. And here customer can set a maximum charge power from grid and the charge and SOC by grid. This is about battery setting. And next one is about backup load and backup output. Customer can enable or disable backup output here, and set the range of backup voltage, and also minimum SOC of backup output. This function we can think like this. In the night time, there is no grid, and there is also no PV, and my battery discharge to supply a load till, for example, 20%. And then in the daytime, there are still no grid, and the PV is okay. And then it's in the morning, firstly charge battery till battery 30%, then the backup output will be recovered. This is the SOC to minimum SOC to have off-grid output. For example, currently no grid, and I connect the battery and my load. Now my battery SOC is 34%. Okay, I can have the system working. If my battery is only 24 or 25%, it's lower than the 30%. So I am unable to put on the system. Okay, the last one is about there are some other settings. Firstly, the customer can enable or disable parallel mode here, and he can also select his battery is connected individual for each inverter, or all inverters are sharing a parallel battery. And some customer may use three single-phase inverter to parallel to a three-phase system. So he need to select this inverter is in phase 1, this inverter is in phase 2, this inverter is in phase 3. So here are the parallel settings. But for your inverter, I think maybe it's required a firmware upgrade to support the function parallel to three-phase system. Another one is about the capacity mode. Here we can select control by SOC, or we can also select control by voltage. For lithium battery, with BMS communication, usually I always recommend select SOC control. But if it's lead acid battery, I recommend use voltage control. With voltage control, customer can set the charge voltage, discharge voltage, and also the end discharge voltage. Yeah. This is about capacity mode and voltage control. And another setting is support normal load. This is to decide whether my battery supply normal load. And this is to decide whether my battery supply a backup load only, or it supply a backup load and normal load together. If you disable, then my battery will only discharge the power that the backup load demand. This is a support normal load. And another function is AC couple. That means to install the hybrid inverter to an existing on-grid system, and they are pairing an on-grid side. This is we call the AC couple. Yes. Okay, my inverter is off. Okay, now this is about the introduce about our app and its Bluetooth local connection function. Now we continue about remote part. For remote part, for end user, he can do remote monitoring by this step. Firstly, register his own account and then log in his account and create a plant and add his inverter. And then he can do remote monitoring. But to have remote monitoring, the first step is to install Wi-Fi dongle and configure the Wi-Fi connection. That is the necessary part. And then for our service team, and for installer, he can use service login to do remote monitoring to his customer and remote management to his customer account, and do remote setting to his inverters. And here are about remote part. Okay. This is yes. Oh, sorry. This part. For this is how can I say, the multi-level management of our monitoring system. For our company is for the service account, there are 3 levels. Type 13 is our company is type 13, and the service account we create to you, SBS admin, that is type 20. And then the sub account you create for your installer is type 10. And then your installer and yourself can acquire end user for monitoring. And the user acquired by your installer is will display on your page also. This is about multi-level management. This is the function and the operation manual of the service platform. Firstly, you get the type 20 service account from our side, and then you log into the service port, and then you create a sub account for your installer or for your service colleagues, and then they can log in their account and to acquire end user. And for SBS admin, he can also acquire end user and also assign the user to other service accounts. And after that, he can do remote monitoring and remote operation to the customer and the device. Okay, now I will have an operation demo. All right, this is our service portal. And we can log in the service account, for example, SBS admin. And after login, firstly, we will arrive the monitoring page. And here you can see the user list that are user in your service account. Here you can add a user to your list by his account name for example, and any devices SN of his account.
What's
this
SN? Sorry, what SN must we put there?
Serial number.
Of inverter?
Yes. Here is to add the end user account to your monitoring page. So
Okay.
he need his account name, and you will need any one serial number of inverter in his account. For example, now I have this is my account, and this is a serial number. Okay.
Okay, so it's inverter serial number, not Wi-Fi dongle serial number.
Yes, inverter serial number.
Okay.
Yeah. For our system, we record inverter data by inverter serial number. Inverter serial number is the Unicode ID of inverter. So here you need to pay attention the correct.
Okay.
Okay. I relate it. Okay, you can find I have added this end user to my service page, and I came here, log in to his account directory, and I can see his prompt, and I can also enter his prompt and see the generation information. Yes. Yes, this is about add end user account.
Now, this user list is where our installers, this is our installers list, right? And they will have all their plants under their list.
No.
Or is this end user list?
This is end user list. Here
Okay.
is monitoring tab and the user list. And here we see is all end user list.
Okay.
And yes, this part you can the sub account is to create installer list.
Okay.
Yes, you can input the information of your installer and create account for him, and then you give this account to him. For example, you create a sub account for your installer, right? Log in by web. So now I create a installer account Lincoln. Okay, it's okay now. Okay, you can find the installer here, and now only no devices are in his account. Okay, and we create, and for installer Lincoln, sorry, he can also log in the service page. Okay, now I in installer Lincoln's page, and his operation is similar to you. He can rate it the account and the user and the serial number.
And for him to log in, he's going to log in on his online portal with service.cloudinverter.net. Then he will add his own user account name and his own password that we create for him.
Yes.
Okay.
Okay. Now he can also edit the this account. Okay. add more end user. If he installed for more customer, he can install. He can add more customer here. But the difference between you and your installer, that they are not available to create one more level of service account.
Okay.
Yes. Your account is type 20, and you can create a installer account. Installer account is type 10. He cannot create one more level. He can only add end user to his
But
account.
we can create end user also.
Yes, you can add end user to your list also. Okay, next page is about global search. In this page, we can search the devices by serial number. Okay, this is device is now belong to the account Lincoln, and it's basic information here. And here we can also search user. We can delete this account, or we can active this account. This is about global search. And for other function like batch firmware upgrade, actually it's operated by our side. Your side no need to do that. When some inverter need a batch firmware upgrade, we will do that. And for you, what you usually would do, it will be here. We go back to the user list. When we click the account, it will reach user's page directory, and we can enter his prompt and do check its informations. And if we click here, operation, here is operation icon. We click operation icon. Okay, we can also see his prompt. And when we enter the prompt, we can see the devices list. And here we can there are operation icons available. The first one is to remote setting. Here, okay, we click the setting page. Here we arrive at the remote setting page. And here we can see the similar functions like we do on Bluetooth connection. For example, here is a grid parameter setting page. Here where he can switch the grid code. He can set the voltage and frequency protection point. And he can do the firstly read the latest parameter of inverter. This is to read. And after he change parameter, he click upload to send the new settings to inverter. And the menu contains grid parameters, feature parameters, and hybrid setting. And it's the same, similar as what we do on Bluetooth connection. For example, the working mode, the battery information, the battery set parameters, and the backup output setting and other settings. And here we can also see the power limiter setting page. He can select the device, he can set the location, and he can set the power flow direction and the maximum feed-in power, and the small power always pushes from grid. And the next page, the other settings is the same to Bluetooth connection. So before we doing a setting, usually we recommend click read to read the latest setting of inverter, and then after we change it, we click upload. This is about remote setting. And another one, this one is firmware upgrade. Here we can select the firmware package, and then click begin to start firmware upgrade, and the inverter run upgrade by itself. This is about a remote setting and remote firmware upgrade. Okay, this is about the service port and its function. Here are also some brief introduce. Firstly, the function and the operation map. And secondly is the login access, the service login. You and your installer, he can log in the service port by web page. He can also, and on our app, there is also a service login. Here you need to pay attention. The monitoring is for end user login, and the service is for service account login. So you need to switch to service tab. And this is to create a sub account for your installer. And this is to acquire end user to your monitoring list. You need to input his username and any one serial number of inverter in his account. And this is to assign user. Assign user, that means I can move this user to another installer's list, or I can move this user to other list colleague for management. This is about the assigned user. And for remote monitoring, we just click the username and we jump to users page automatically. And this is about a remote setting. This step is to click the operation icon and then enter the prompt and enter the inverter list and click setting icon. And before setting parameters, read to obtain the latest data from inverter is necessary. And after setting the parameters, we just click upload. And this is the step of firmware upgrade. We just click the upgrade icon and upload the firmware package, then get started. And this is about function of global search. We can search an inverter by its serial number, and we can get the information this inverter belong to, and we can also do the we can delete it from calendar account, or we can change the inverter to another account, and we can also do upgrade and settings here. And this is to search user. This page we can input username and search his account. We can delete his account. Okay, this is about a function introduced about the service page for you and for your installer.